So tell us a little bit about Radical Numerics and what inspired you to found it.
Absolutely. Thanks for inviting me here. Radical Numerics is a new research lab, and actually our team is known for working on a model called EVO, which is an AI system that could read and write DNA. And it actually got some traction, got on the cover of Science and Nature. And then scientists actually used EVO recently to generate the first whole genome from scratch using AI.
Wow.
And it turns out it's this organism called a bacteriophage, also known as a virus, which was a really big turning point for us because we realized that this was a very potentially powerful technology, both for potential human health applications, but also a huge concern on the biological risk standpoint. And so we actually started the company to work at the frontier of this intersection, both driving the capabilities and frontier of biological AI design, but also ensuring that technology is safe. So we actually work on biosecurity applications as well. So making sure that the technology is safe and preventing it from misuse.
Wow, that's fascinating. So when you first founded it in 2025, what was the AI landscape back then?
Yeah, I kind of like right now, except perhaps even now it's even more feverish. But at that time, when we started the company, we actually were trying to stay away from working on science and AI applications. It's had this sense that people didn't know how to turn AI into actually a commercial effort in the life sciences. But after we started the company, folks did come to us asking about what we could do and help them make models. And so it got to this point where it was a side bet for us working on biomodels, but then eventually came the main bet. And I think it was really at the time it was this flavor of agents, coding agents being like the main thing, and like, is there value in working on the foundation models or being the layer on top? And so we actually took a bet on building the model side, but in a different domain, which is in this space, bio. And so we're glad we did because I still believe that the space of the value being around the core models themselves is something we truly believe deeply. And so we think that's lacking in the bio space, the life sciences space. Very strong, capable models that can actually learn from data at scale. You just don't see that unlocked in science yet. And so that's one of our aims, is to actually show folks that we can learn from biological data at scale and perhaps work on an application that, in my mind, is the most important area of AI, life sciences in the physical world.
And you're still very much at the frontier of this work too. And so one of the things that I'm curious about is, you have a very interesting background that led to this journey. So you started off first in civil engineering, and then you worked in management consulting for clean energy, and then civil engineering and computer science masters, and then a PhD in biopharma.
Yeah.
And can tell us a little about how this influenced your thinking about your current product and what you see as the vision ahead?
Yeah, it's a good question. Lots of jumping around. To be honest, basically didn't figure out what I wanted to do and just stumbled my way through. But overall, I'd say it got to a point where I knew I wanted to do something around tech. I knew I wanted to do something meaningful and impactful. And so actually, when I went back for a PhD in bioengineering at Stanford, the hope was that I'd find a path around folks who were entrepreneurial and mission-driven. And so I think what really helped me along that journey was the degrees don't really matter. It's going to be self-driven. It's going to, the things that are going to be able to push through, you have to drive it yourself. And so I think the influence of being in a place like Stanford for my PhD, multidisciplinary and sort of the intersection of fields is where I thrived. And so being at this intersection of AI and biology, I can see why it has been difficult for other folks in the community to actually have impact and sort of unlock things. And so that's what we're still trying to do, right? And we think we have a recipe, we have a strong thesis about how to do that. And it's really at this intersection of multiple domains, but also in this particular case for the company, we have a really big thesis around multimodal. In general, like a lot of the way science or biology in particular has really developed over the past 50 years or decades, is usually like one specialty at a time, like people who understand one disease, one gene, or one modality, and then hope that they can somehow connect it all together if they learn, one specialty at a time. And I think that's what's been holding back the field, because biology is super complex. Our bodies are extremely complex. Disease is complex. And having this ability to understand the entire system at once is something that we're working toward unlocking. And the idea of a single general biological intelligence is something I believe is what's going to unlock actual progress in the space. And so that's what we sort of landed on in this journey, and it's what we're seeing as a company. And we're super excited to share more about with folks. We'll be sharing more in a couple weeks. But just to preview that concept here a little bit.
Yeah. Also, I think you're being like way too humble, because you were on like a TED Talk. You wowed the crowd with like your vision for like genomics, and I do believe after talking to like a lot of other folks that the interdisciplinariness does help in thinking about how to apply models in like novel ways, which I think definitely makes the case for radical genomics here. So could you tell us more about like your approach to multimodality?
Yeah, absolutely. When I think about multimodal in biology, I sort of think biology is kind of made up of many different languages. So you have grammar around DNA.
Right.
DNA is our genetic code. It has all the instructions for making an organism. And it basically follows some kind of grammar and rules. It turns out it's an extremely complex, perhaps one of the most complex languages ever. And it's just one of them in bio. Because there's also proteins. There's also RNA. They all stem from DNA, but they all are pretty specialized, but they're all connected at the same time. And so for us, that's been the challenge for folks. People thinking that we have to specialize in each of these domains. We have to have a mono-specialized for proteins, a mono-specialized for DNA, mono-specialized for RNA. But these things are all part of the same system. And when disease happens or when a drug is in your body, it's inherently a multimodal system. It has a cascade of effects that affects each other.
Yes.
And we believe, the ability to model that is what's been holding back the field. That's why it takes $2.5 billion to make a drug or over 10 years. And that's why we can't figure out how a drug's going to behave in a body, because it's an inherently multimodal system. And so for us, we have now this incredible technology that is AI, the best pattern recognition machine in the world, the best ability to show that modalities can be merged. And at the same time, it's being applied to sort of, in my mind, the low-hanging fruit, things like text and images, which need to be done. They should be done. It's obviously super useful. But the next frontier is clearly, in my mind, it's the physical world. This is where the rubber meets the road. And in many ways, multimodality in bio is best set up. Bio has an inherently multimodal problem. And so for folks interested in this space of, from a technical standpoint, multimodality, biology has the best setup, right? It's massive scale data, dozens of modalities, if not more, and potential for huge impact. And so that's been our bet, because when we see the companies that have tried to do this, it's just nothing seems to work. Nobody's really meaningfully making multimodal work, yet alone making scaled models that work in bio. There's just so much behind in the space that there's a long road ahead. But clearly, this is going to be the most impactful area of AI. Like, what is more important than human health? And so I think more and more you'll see labs, people working in the space, and you already see it, like Anthropic and DeepMind, OpenAI, all having more initiatives in bio and life sciences, but it's a different ballgame. And I think they'll see that the challenges of trying to apply AI to the space has its own unique set of challenges. but then at the same time, it's the most worthwhile thing to work on.
Right. I mean, first of all, I love like your metaphor of having like, the proteins, like you being trained on different like models being not efficient because like the body is communicating with each other like synthesis, right? Like, so if you think about like kind of like paragraphs and says merging together as like, different proteins, like they are affected in like a bigger entity versus being like in silos. So that's a great way to think about it. I've never heard like multimodality applied to like human biology with like that metaphor, but it makes a lot of sense because like pattern recognition is like, how like the multimodal is like merging these like paragraphs and forms, but it could be used as like, how they would like merge together different molecules.
Absolutely.
So
Absolutely.
grammar of the body is very interesting.
Yeah. And it's super important and super challenging. It's kind of like another analogy, moving away from the language one. It's kind of like when I think about how scientists have learned about biology and our bodies, it's like if you were to make an analogy about a person's body as a car. Let's say if a biologist wanted to learn how a car works, they would study like each part, like how an engine works, how a spark plug works, how the tire works, one at a time. But if you ask an engineer how a car works, they're not going to study one piece at a time. They're going to try to rebuild the whole thing from scratch.
Right.
And each of the pieces, how they fit together. And I think that's, in many ways, what we're trying to do. When we first started working on DNA specifically, we worked on a model called EVO, right, as mentioned. What we were trying to do was understand how life is built from the ground up. No one had used AI to generate DNA from scratch. It was thought to be too difficult, the rules unclear. Humans don't even understand it. How can you teach AI to do it? At the same time, if we could unlock that, I believed, that would change things. And eventually people did use EVO to generate a whole genome from scratch, as I mentioned before, bacteriophage, virus. And in that process of rebuilding things from the ground up, I do believe we are going to drive more deeper understanding because we're going to rebuild that car up from the ground up and understand how all the pieces fit together, and not in isolation, but as a whole. I think that's super important.
I agree. I think there's like, it teaches the appreciation from the ground up, but also teaches kind of like, caution, right? So that's why I think like, what you're doing is fantastic because you use this knowledge to kind of like reframe the situation and think like, given that we know this can be done, how can we also create like, counterproductive effects? And as Radical Numerics, like, you guys have like already made quite a bit of progress. And so I've imagined, I remember you first told me like the EVO Model 1 had like 121,000, like
131,000. Yeah.
And then like EVO 2 was like 1 million. So like the next one might be like 1 billion. Like that's an amazing kind of like, progress in terms of scaling context.
Yeah. It's a measure of progress, context length. It was one of the key things that we had worked on for the technology to unlock because before we worked on DNA language models, contexts were super short, like we're talking 4,000 tokens. And we had developed this new architecture called Hyena. We could use it on extra long contexts, super long. And at the time, text just didn't have that language, natural language, didn't have that much interesting long context problems. And that's how we gravitated toward DNA. We thought, what's a domain that has the longest sequences? Turns out DNA is pretty much the longest that I can think of. The human genome, right, our bodies, it's made up of 3 billion letters with 3 billion tokens, right? And that's basically the equivalent of about 30,000 books. And like in my mind, that's a key number, right? Like how can we get to capture the entire context so that we can understand all of the different sort of dependencies and motifs that kind of interact in the same way that we model language and code. We care about the long context in those domains, but for our genome, our DNA, this is a domain that makes us exactly how we are, right? It's the very DNA of ourselves, right? At the same time, it's wild to me, and I think probably for a lot of people, that we actually know very little about our own DNA and how it actually works.
Right.
And so I find it interesting that we've been so caught up with using it on language, and that writing emails and helping you with your homework is great. We should absolutely do that. But using it to unlock how disease works in our body and how you can potentially make precision medicines to cure, like that, does it get more impactful and better than that? Like that's, in my mind, the coolest potential application of language models in AI systems.
Yeah. That's very inspiring too. So like kind of going on that, like what do you hope is on the horizon for you for this year?
Yeah, so this is it's a very exciting year for us. We just closed a seed round recently, and this year we plan to preview some progress on our models, our next generation of models. And the idea, we alluded to multimodal before. We started off with genomics as a team. One of the things we learned with the EVO projects was that DNA was not enough. It's a key building block for life and biology, but as we mentioned, it's just one of the languages. And so we wanted a single system to understand not just DNA, but also proteins, RNA, epigenomics, metabolomics, all of these omics that people use to describe the different disciplines in biology. Now, for us, the idea is to fuse all of these modalities into a single system. And we believe this is going to unlock pretty much applications in every domain in bio. Pharma, diagnostics, synthetic biology. We will design we are designing whole genomes as a company now. And so that is one of the reasons, that is a key reason why we also work on biosecurity, which means to us making sure that the technology is both safe about what we enable, but also actively defending against other potential threats that biological AI enables in the first place. Right. To us, it's inseparable. If you're going to work at the frontier and pushing capabilities of AI to be able to rewrite the very fabric of our biology, you've got to make sure that the technology is used to safeguard against it as well.
Yeah. And I also kind of want to bring up that even though you're working on such like amazing frontier tech, you already have like existing partners, like established systems. So it's not like a lab experiment. You have like real progress and support for this.
Yeah, absolutely. So I just finished a PhD at Stanford, and very great experience, and had the privilege to be able to publish the EVO work in the cover of Science and in Nature, and I think the phase of academic accolades is important, but also to me, the real value is you got to bring this in the real world. You got to such powerful technology, the potential of it. It's not enough for me to just showcase like this is theoretically how it can be done. Right. But our goal as a company, we want to reimagine what folks can think about what these models can do. But we also want to put it in their hands, and we also want to save lives. Like that is one of our key metrics as a lab inside the company, is how can we actually use our technology to save lives, like concretely. None of that theoretical, like, oh, we want to do good. Right. No, we want to actively get this in the real world and to save people's lives.
And I feel like, like from today's conference, from like generally there's like a movement, there's an energy where people are starting to like merge like, theoretical, like our AI kind of model focused research onto real world applications. I mean, the theme of today's like an event like is with Google DeepMind, there is a track around like, multimodalities. There's a track around like sciences. You yourself spent some time like with the DeepMind team like just last summer. Yeah. So tell us a little about like like what you feel not just from like your company but like kind of from the surrounding ecosystem that's supporting this movement.
Yeah. It's incredible to see the excitement around science now, because there wasn't that much before. Yeah. People were really excited about just getting chatbots to work and answer questions and do math, and but now I sort of think, and perhaps many people think, that sort of like the low-hanging fruit is taken in terms of like the traditional AI domains, text and language, and this natural movement toward, okay, how do we get this more, to be AI, this cool AI technology to be useful in the physical world, the next frontier, right? And so you're seeing obviously lots more of this about automating labs and multimodal as well. And so I think great that there's excitement on about it. At the same time, when I was interning at DeepMind last year on this co-scientist team, and I love what they're doing. It's brilliant people, but clearly the frontier labs, their main incentive is to drive chatbots and image generators and code, right? These are clearly the money makers, and science is like kind of like a side project to like show that the main models are can work in those spaces, but like they're gonna sell like to enterprise and coding, agents. I think science, health, bio is too important to be a side project. It needs to be a main project, and so that's really a key motivation for why we started the company. We wanted to bring frontier AI technology, but it's not going to be a side bet. It's going to be the main bet. And so I think that's important for a lot of folks to see alternatives for where their skill sets in training these incredible machines, these incredible intelligent machines. You can work at companies that focus on, mission-driven, real impactful products and goals. You don't have to do it as a side project. It can be the main goal.
Yeah, and I also want to say, even as a subject matter, to encourage like young researchers to like develop more interest in like researching the intersection of like AI and bio. There's so much rich data, so like people should know that like this is an exciting, fascinating field to dig into, versus like thinking that they can only go into like certain types of like models, worlds, etc. So
yeah, I love that. So you mentioned data. Data, obviously is like a fuel for AI. You need lots of it. And when I first started working in the space of bio, maybe about 4 years ago, everyone told me that this was like a data poor environment, and that that's what's holding the field back. But I actually disagree. And just starting with DNA as an example, there is more DNA online than all of the text on the internet. And that's just one of the modalities, which actually is actually one of the small modalities of bio. And so this is internet scale data. And at the same time, people have been basically learning or using this data with like linear regression or logistic regression, basically very simple models. And I think that's why people kind of come back to this idea like there's not enough data. But I think it's because the methods being applied to it have not been as powerful. And so that's made people want to just get more labeled data and think that they're going to just power their way through just getting a bunch of expensive annotation data. But I think that's one of the reasons why we worked in genomics first, generative genomics, was the fact that there's this huge treasure trove of data that people think is not that useful, and it kind of reminds me a ton of like how people thought of this pre-ChatGPT days, like pre-language models. It's like, I don't think people understood the value of all that data. Like we definitely didn't until language models was able to figure out how to aggregate all that data, extract that small amount of signal from each token, and then apparently create something powerful. I think we're in that moment for science as well, that the recipe is still out about how do you design an architecture, how do you actually learn from data, how do you evaluate them. And so this is why I think this is the next frontier. There is a lot of data, and there's still a huge amount of stuff to be figured out from an AI research perspective, which makes me super excited about it still.
Yeah, and I'm super excited for like your company's like growth. Is there anything kind of you wish to like communicate or like kind of share out to the community? Are there any like partners you wish to work with? So.
Come work with everybody. Come work with us. Yeah. So I think we intentionally design our models to be flexible to work with any type of biological data. So that's kind of generic, but to be targeted about that, I think just more broadly, one way to get this question is there is a massive amount of data in the biological space and life science space. It's just guarded behind. It's also guarded a lot behind existing pharma companies about the clinical information, the experimental data that they collect, it's interesting to see that a lot of these companies are just sitting on it, and I presumably waiting for other folks to unlock it internally. I think in general, a good idea at this stage is we do want to work with partners to showcase that we can unlock it together. And so we are actively looking for design partners at the pharmaceutical side. But we also work with diagnostics, and I mentioned synthetic bio and biosecurity. So that's a lot of governments too who have a lot of biobanks. So this is like entities that capture like genetic data from patients and like a lot of information about their health essentially. And we're interested more so because, not just commercially, but like more so the fact that there's this amount of much data and like still very little utility that is actually be gleaned from it. It's just such a shame that we haven't been able to train single models or single systems to be actually useful on this type of data at scale in a way that just doesn't plateau, which is usually what happens in terms of performance. We internally have been seeing incredible amount of modality transfer and scaling laws occur in this multimodal data that we're working with. And I think we're just at the beginning of starting to showcase to folks that this is possible. And so this year is going to be a year really focused on getting folks to, like I mentioned, reimagine like what's possible from data at scale in life sciences.
That's awesome. And we're very happy to have people like you working on it.
Thank you. Appreciate it. It's been a pleasure chatting with you.
It's been a pleasure.